Fission and fusion. Does anyone know what fission is?
The superhero. Vision. Oh, Fission.
Splitting of an atom.
Got it right. Thank you.
It's when a large atom breaks apart and becomes smaller. What is fusion?
It's whenever you fuse something together.
Yes, it's when two atoms stop talking, fuse, or combine together to make a larger atom. So it's small atoms combining to make a bigger atom. Atoms smaller than iron 56. So that would be 5628 Fe. Are, and I never remember this because we always use iron. It's technically not iron, but the other isotope, there's no easy way of making it. It's technically more stable. Or is it? No, it's nickel. You should just remember iron because everyone always states it. Nickel 62. And this is wrong. This is 28 and iron is 26. Looking up and confirming this. Yeah. So atoms smaller than iron 56 or nickel 62 release energy when they fuse together. Undergo fusion.
So, like, hydrogen.
Yes. So they're going to release energy when they fuse together. atoms larger than iron 56 slash nickel stop 62 release energy when they undergo fission.
I have a question.
Yes.
Nickel, well, why did I add nickel to?
So theoretically, nickel. So let me write that down.
Because I,
Nickel 62 is the most. Is theoretically the most stable element in the universe. However, iron 56 is more commonly made via nuclear synthesis in stars and is the second most stable element in the universe. Because of this, because iron 56 is made more naturally in stars, it's often called the most stable. At the end of the universe, all atoms smaller than iron 56 will fuse together, will undergo fusion, and become iron 56, and every element larger than iron 56 will undergo fission to become iron 56. Therefore, at the end of the universe, all atoms will be iron 56.
it will be iron. So, basically, everything in this room will be iron.
This is after they all go into stars. They blast it away, combine together. Eventually, this is billion years from now. Even larger than that.
I thought that'd be silver surfer or something.
The Earth will have long been blown to smithereens and turned into dust by then.
Oh, Magneto would die.
So, how are all the atoms produced in the universe?
My God.
So, how are all the atoms? Where were the atoms in your body made from?
God.
But where were the atoms eventually made? Where can we trace them back?
The Big Bang Theory. My mom and dad.
We can trace them back to the heart of the star. All elements larger than hydrogen, and I think helium, and maybe helium. I know almost every element bigger than hydrogen, and some of the helium maybe. And I'll put that in percent, maybe some helium. Were made in a star. So let me see if I can actually look up. You don't need to know this term, but if you're curious, it's called stellar nucleosynthesis. So at the Big Bang, everything was too hot to come together and form atoms. So if you didn't know this, we had the Big Bang. After the Big Bang, when the temperature of the universe decreased to the point atoms could exist. The only atoms were hydrogen. Due to gravity, this hydrogen gas collected together to form stars. The intense gravity caused hydrogen to fuse together. So let's look at some of the reactions that went on.
I just want to see a big explosion. And that the shit was on air affected and then boom. It's just everyone hanging out here.
So we have a hydrogen atom coming together to make a with another hydrogen atom. So two hydrogen atoms colliding. To make another hydrogen atom.
You know you still have that folder thing over the periodic table.
Yeah. Y'all should have y'all's own copies. Plus another particle. And you don't need to know this, technically a neutrino. You can ignore that neutrino.
What's your
just a particle.
It's just another one, I guess.
So, what is this missing chemical or thing? You could technically combine this together. There's a sub-reaction, but it doesn't exist too long. We could look at this. This makes... So, 1 plus 1 is 2. 2 plus 2... 1 plus 1 is 2. So, this is helium. But helium will very quickly, with only 2 neutrons, or with no neutrons, will break apart into this. So, 1 plus 1 is equal to 2 plus what? So, 1 plus 1 is equal to 2 plus what? 0. So 1 plus 1 is 2, and 2 plus 0 is 2. So, 1 plus 1 is 2, and 1 plus what gives you 2? 1. And what is this? This would be a beta. This is a positron.
This is like Transformers.
Now, this new chemical, this new element right here is deuterium. But it's unstable, eventually break apart. But sometimes before it breaks apart, another hydrogen will come in here and hit it. What do these two make whenever they collide together? So 3 over 2, and what element is that? Helium. 2 corresponds to helium. And you don't need to know this, it technically also does a gamma, which is energy, which is 0 over 0, which doesn't affect this.
That confused me. He was going with it here.
Now then, eventually 2 of these will be produced and will randomly hit together. So 2 helium nucleus, helium-3, will come together and make a helium-4 element along with some hydrogen. How many hydrogen will be released from this? So the top number, 3 plus 3 is 6.
Yeah.
4 plus some number times 1 gives you 6. What would that be?
2.
Thomas, lift your head up off the desk. So we need to have 2 hydrogen. So 4 plus 2 times 1 is 6. 2 plus 2 times 1 is 4. And 2 plus 2, and this element is stable. So through this series of reactions, we eventually, inside of a star, make helium.
And then eventually the helium, you make it the next thing.
It actually doesn't.
Does it? It's on the periodic
No, it
table.
makes iron molecule.
So currently we have inside the star these 3 elements that are constantly being made.
They so handed it to me.
That's 4.
So the next element that is made is whenever a helium-3 hits a helium-4. So it's going to make some chemical plus a gamma. So energy.
Beryllium.
This would be beryllium. So 2 plus 2 is 4. And 3 plus 4 is 7. And then the zeros obviously don't add anything. So now we have a new element inside of a star. And occasionally, this new element will be hit with another hydrogen. Boron. So 4 plus 1 is 5. 7 plus 1 is 8. And then there's gamma, but we can ignore that. So now we have this one. However, this is unstable. It's very unstable. So it is going... So all of these other reactions have been what? It's two atoms coming together and making a bigger one. So that would be... Fusion.
Fission. Fission.
Fusion. And keep y'all's mask up. Brent, keep your mask up.
Mr. Woods, what? After school, we getting away with. You wanna come with us? After school, we're getting away with. You wanna come with us?
So, this is the first time in the series it undergoes fission inside of a star. So, the type of fission this produces is a beta plus. So, what would be the equation? So, we know it's going to make something smaller plus a beta plus particle. So, what element is here?
Beryllium.
So 5 is equal to 4 plus 1. And then we have 8 is equal to 8 plus 0. So this is beryllium.
Got it.
And now we have another isotope of beryllium. And that one's stable. Actually, let me look up the stable isotopes of beryllium. That one's actually not stable either. So, looking up the stable isotopes of beryllium, the only one that's stable is 5. Is 9. Beryllium 9 is the only one that's stable. So that means this one is going to break apart too. Yes? Mm-hmm. And it makes a helium atom plus something else.
Another helium atom.
Exactly. So we can simplify this as making 2 helium atoms. So, for the first phase of the sun is mainly converting hydrogen into helium. Let me just do hydrogen into helium. Most of all these reactions are going to continue. You're eventually going to get back to helium. You do get some few other chemicals or isotopes, but they're mostly unstable. Some of them aren't. And it mostly will continue like this. There's other ways we can get it. I'm trying to look up. But for the most part, the star is mostly going to be converting hydrogen into helium. Eventually, all the hydrogen in the star... Guys, lift y'all's heads up. Thomas, lift your head up. For the most part, we're going to be converting hydrogen into helium. As long as we have hydrogen in the sun, in the sun's core, this is going to be the net of our reaction. Does anyone know what happens to our sun when it runs out of hydrogen in the core?
It's gonna explode. Boom. No more galaxy.
What's the next step for a star? Have y'all learned that in
Yeah,
junior
Fade
high?
out. They go away.
You know how to start? You know the biggest star?
The sun, the bigger sun's out there. With
Yeah.
stars.
The shiny thin stuff everywhere.
That's just scary. You know, what if also explodes? And it goes into another galaxy? What if that's done? If it goes away?
Thomas, you bother me thinking.
It'd be like negative 20 in like winter, and then it'd be like 120 during summer.
Bro, you also about there say that we went to a different alternate dimension at the end of 2020.
So why doesn't the star just collapse a single point as gas? There's a lot of gravity in a star. Why doesn't gravity just contract all of the star down on itself?
Because they don't want to.
Here's another thing.
It was like, you had to say whatever.
Why doesn't it pull all the why doesn't it pull all the gas around it down to a point?
Because helium floats.
Mm-hmm.
Boy, it does, man. If you suck it in.
So what happens if you heat up a gas? What happens if you heat up a gas? It expands. So the nuclear fusion going on in the center of a star pushes or creates a pressure, keeping it from collapsing.
So basically,
So as long as it has hydrogen to continually release energy, so remember that whenever two hydrogen fuse together, they make some stuff plus energy. That energy goes into heat, making it expand out. Whenever it runs out of hydrogen, it's going to shrink a little bit. And what happens if you take a gas and you compress it to a smaller point? It heats up. If it's explosive, it will explode. But as you compress gas, it gets hotter, which makes more energy to start fusing helium together.
So why don't we just use gas?
We do. We use natural gas and we burn it.
When we use helium and hydrogen, wait, is that natural gas?
Natural gas.
So the sun, for the most part, is using fusion to generate energy. It does have fission going on inside of it, but for the most part, it's mostly fusion. The heaviest elements actually occur during a supernova. Does anyone know what a supernova is? It's whenever the star starts collapsing into a single point. It starts getting smaller and smaller and smaller and smaller until it can't get any smaller, and initially it gets so much pressure it causes it to explode outward. During this explosion, it's so energetic that things fuse together to make your heavier elements. And this is where all the elements in the universe are made from. Inside of a star, just fusing together elements like that. We're all stardust. Every atom in your entire body was made in the core of a sun.
I'm confused.
And God made
It's not confused, I'm just like...
So every atom in your body was made inside of a star.
So what, a star?
You are stardust.
So whenever I tell someone a star, it's not a compliment, it's just talking to them.
You're not a star.
You are made from the death of a star.
Yes?
Yes.
That's
A star a long time ago exploded, sending its guts out to the rest of the universe, and that is you.
That is sick. I'm starting to...
I didn't even know I wasn't playing the b-ball.
Yeah.
Wait. Jesus, we're now. Here's our
So let's do some example problems together.
Everything I believe in. Does Fission have feet? No.
Have you picked up fish and look at it? But there any feet on it? They have fins.
I looked at it with a magnifying glass. Exactly.
You're stupid to do that.
They may have small feet. Mind blown.
You probably want to think snakes have feet too.
They do.
They don't.
They have,
They contract. And stuff.
they have very tiny little feet on their scales to make a really decent. Do you do that like intro to inch or?
Alright,
Oh wait, intro have feet off.
so let's say polonium
Those feet.
it's hit with 2 helium
I don't like.
plus 2 electrons.
Don't get on the phone.
What does it make?
I know this one. What's going on?
So the top numbers is 214 plus what is 2 times 4? Plus 2 times 0 equals what? 222.
I was right.
So the bottom number is 84. So this number in front is multiplied. So 2 times 4, and 2 times 2 is 4. And what is 2 times negative 1? Negative 2. So what would the bottom number be? What'd you say? Yeah, 86. And what element is 86?
That big one.
You'll need to have y'all's periodic tables.
I lost mine. I lost it in my backpack. My backpack ate it probably.
86 is
Radon.
radon.
I don't even know
Radon.
what
Redonkulous.
What's the line? Got him.
So these numbers in front are multiplication.
Ugh. Get my pen. There you go.
So, oh, by the way, is this fusion or fission? So we look at the largest element, and then we compare it to the largest element over here. It's smaller. No, it's not. It's bigger.
Fusion. What's that?
So it's fusion.
What's that?
It's gotten bigger.
I said fusion.
So nitrogen is hit with some mystery particle and turns into oxygen.
Hydrogen. You said it combines with hydrogen.
What is in here?
Medium. Hydrogen.
So we have, let's look at the top numbers.
Hydrogen.
14 plus something is equal to, what's 17 plus 1? So what plus 14 gives you 18?
Or it's hydrogen.
And then we do 7 plus something. What is 8 plus 1? So, and 4-2 is alpha particle or helium.
I knew it. You gotta get back. I didn't need it. You didn't need it.
No. So some mystery particle was hit with an alpha particle. It releases carbon 12 and 1 neutron. So we have something plus 4 is equal to, what's 12 plus 1? So what plus 4 gives you 13? Nine. And then we have, for the bottom number, something plus 2 gives us 6 plus 0. So that'd be 6. So it'd be 4. And what has an atomic number of 4? Beryllium. Yes.
Well, you know.
Exactly.
Wait, how did you get 9 plus 4 equals 13? Now you have
Right.
9.
Guess who's starting right
9 plus 4 is equal to 13.
Hunter Werner.
I don't think like
It's Hunter Werner.
Yeah, we have 9 people.
Hunter Werner started.
Yeah,
Yeah, I can come start right now.
So we literally.
So does anyone know how a nuclear bomb works?
Yes, sir. It's by one atom and another atom.
So we have uranium 235, nuclear grade of uranium, and we take a single neutron and hit it. It produces 2 smaller elements and sometimes 3 neutrons. These neutrons can then hit another uranium 235 and split it again, creating more neutrons.
Look at this uranium. I thought it was like 120 or something.
These neutrons can then go on and hit another uranium 235, and then they can produce, so each of these 3 can hit another uranium 235. And it's a chain reaction, continually making more neutrons. So let's write the equation for this. So we have uranium 235, its atomic number is 92, and we're hitting it with 1 neutron. And it makes this chemical, this element, plus something else, plus 3 neutrons.
I'm just gonna burn up on your team now.
Y'all quit talking. So let's compare the top number. The top number would be 235 plus 1, the arrow's an equal sign, is equal to 87 plus something plus 3 times 1. So let's simplify this. What is 235 plus 1?
100 and
What is 3 times 1?
140. 140. Come out.
So we can combine the 87 and a 3. 87 plus 3 is 90.
Oh, that's that plus 3.
And what plus 90 gives us 236? 146. So this top number is 146. Now let's do the bottom number. The bottom number is 92 plus 0 is equal to 35 plus whatever this bottom number is, plus 3 times 0. What is 3 times 0? And when we add 0 to anything, it doesn't change it, so we can remove that. Again, plus 0, we can remove that. So we have 92 is equal to 35 plus something.
57.
57.
That's cat.
So what element is 57?
Oh, thorium.
Keep y'all's mask up.
Land to time. Land.
There you go.
Test.
Land. I'm gonna try to land with land. Level. Walk far. Michael, no. Michael, read this. Put it down. Can we sleep with the pet doctor?
Did we have?
No.
They're like 7 minutes.
7 minutes and then
It's 10:21. We have literally 6 minutes.
I can literally put it in my house and tell me though.
Maybe we're like 10 minutes.
What type of reaction is this?
Sir?
What type of reaction is this?
Fusion. Fission.
Fission.
We have something with a mass of 235 converting into two things that are smaller than that. So it's fission.
Caught it. I knew it.
Even though we have two things coming together, fusing together, the net, it's still fusion. Because we have something that has a mass of 9 becoming something with a mass of 12.
Do you play Minecraft? I heard they make it.
Promise to need to have a conversation with your coach.
What about basketball?
Dude, y'all had a basketball team right now.
It's Austin. I'm practicing.
So let's do another example. So not always. Whenever you hit a uranium atom with a neutron, sometimes it makes different things. It's kind of random what you get out of it.
Wait, with the what?
So anytime you hit uranium-235 with a neutron, it's kind of random what you get out.
You get like thorium and Einstein and stuff.
So let me show you an exception. So, what would go in the box? So let's do the top again.
Alpha.
The top is going to be, so the top number is 235 plus 1 is equal to 141 plus 92 plus whatever this top number is.
92.
So this is 236. What is 141 plus 92?
It'd be 2. I have 2.
What is 92 plus 141?
232.
233.
You just add 2.
So what do you add to 233?
Wait, you said 235.
235 plus 1 becomes 236.
Oh.
You add 3. This top number is going to be 3. Let's do the bottom now. So we have 92 plus 0 is equal to 55 plus 37 plus something here. 92 plus 0 is 55 plus 37. So what is in the box?
0.
There is no particle that has a mass of 3
And have a proton.
and no charge. What's something else that we know has no charge? So there's nothing that has this. A neutron. A neutron is 1, 0. So how can we better rewrite this? We're going to put a 3 in front and a 1 there. So 3 times 1 gives us a 3 on top. 3 times 0 is like that. So this is the exception. When you get neutrons, you'll get multiple of them. If you get something with 3, so if you get something like this, a 0 on bottom tells you it's a neutron. A 0 on bottom with a positive number on top, or I should say a non-zero number on top, tells you you have X neutrons. X number of neutrons. If it's 0, so 0, 0, tells you it's a gamma ray. So tomorrow we're going to do a homework packet over those.